Okay, so welcome to the next video. In this video, we're going to do EDA. So before EDA, I'd like to go through the data we have. So I just want you to understand what columns we have and what is the meaning of each column. Then we will do perform EDA. So in EDA, like I just want to tell you like in what way exactly we perform EDA. For that, I have some notes also, but uh, let me see. So okay, I'll anyway. So see, the EDA basically done in three parts, I would say. First is like you do univariate analysis. For example, you have columns, you plot the what I'd say the PDF or whatever PDF and that histogram and that. Right. So for each field, you plot this and see is there any like the distribution is very normal or is there any spike or is there any what like the distorted bell curve? I don't know. I just missed the name. What do you call that? Yeah. So the slight shifted or whatever you say. So is there something in event analysis that is of course you have to see. Then we do a bivariant analysis, which is mostly done by I would say that heat map and the pair plot, in which, for example, in pair plot, in diagonal elements you get the that whatever I just said, univariant plot, that histogram or that PDF plot, and the non-diagonal element have a scatter plot for pair of each field you have, and then you have heat map, which actually tell you like how much one is correlated to another one. And then we have a trivariant analysis, and of course, you could do that also, but there's not much sense of doing that. Even bivariant is enough for like for getting sense of is there any dependency or not. If I go further, then you have to extract the information. For example, if you see that these are the feeds, which is very. So next is like you have like have to divide data in categorical. So there are two type of data: numerical data and the categorical data. So you have to understand like on categorical data what you have to do because we have categories and we have different categories. So we have again you have to plot that histogram will plot that bar plot to understand that the data is uniform or not with respect to the target variable, of course. So let me go to the notes one because we don't want to miss anything. So I hope I have covered everything there, but let me see once if anything or left. I really don't know why this guy is not okay. Okay. Yeah. So you have univariate analysis in which is numerical column or maybe there's a categorical column. In categorical column, you have count plot, which is very important. The I said like that histogram or the bar plot, right? Not histogram, sorry. Histogram is for numerical, not for the categorical. Okay. So uh, for categorical, you have to do that count plot. Then for numerical data, you have to histogram, disk plot, the distribution called KDE. I just forgot the full form. So they actually for histogram, it actually make that bell normal curve for that, right? Then we have box plot is very important. Box plot, right? So it actually tells you about the outliers. If any outliers you have, you can identify that using what box plot, and it actually gives a range and so many things. I'll just show you after this discussion. Okay, so you have box plot. Then there's a bivariant analysis. I just told you it's mostly pair plot, and what should I say? And that heat map. These were enough, I guess. In multi-event analysis, we have scatter plot, very important, numerical versus numerical, of course. Uh, it gives a relation or whatever is this. Okay, there is a bar plot, which is very important. Bar plot is for numerical versus categorical, right? So if I have some category which has numerical data, we plot in a bar plot, of course. There's again box plot I can plot, which is not much important, I guess. I guess it's done line plot and okay. And these kind of plots you have to make and get the inference. This is what you have to do. And that inference is very, very important when you are doing that model analysis. So because sorry, for feature engineering, because in feature engineering you have to extract features and you have to left out some features. You have to exactly delete some features from your data set. And you can't train all of your data for a model because you want to extract the meaningful data you have, and on that you have to train the model. Very simple, right? So first of all, understand this way: do EDA and, and get an idea of the important features you have. For numerical, you could see that pair plot or whatever you see the heat map, and for categorical, you can look at p values or there's so many things. A p value, and there is something called correlation or I don't remember exactly. I'll show you this. There's so many things. I mean, even what I'm going to do in this video for EDA, this is not a comprehensive way. It's not a comprehensive way to do EDA. I'm doing this because I found this is a more speedy plus more easy way to do. I mean, yeah, there could be a more sophisticated also do EDA. I don't know. So I'll just share my screen and start with this EDA thing. Let me open my VS Code first, where I have written a notebook. If I'm not able to do this, I press the author. Okay, uh, that's not opening. In notebooks, I have EDA. Uh, okay, let me share my screen first. Let me share this, right? And I have to share the screen, right? I hope my screen is visible. Of course. Okay. So this is a very simple notebook for feature engineering and EDA, right? And this is actually pretty long if you see, because I have tried so many things. But I'll just go through one by one, and because it's not very much. Okay, so the first block is for importing things. So I have to go to Pandas, NumPy, Seaborn to plot stuff, and Matplotlib, of course. This is for directory. So because I have to import data from another folder, that's why I use this. It's nothing much. Yeah. So this is uh, the transaction data set, and this is the user. Okay. First of all, I have to show you the data, right? Just wait for that also. Mm, the same thing, which is transaction.csv and fam user.csv. Okay. Fam user and fam transaction. Fam user.csv. This is so bad. I should open this on Excel, I guess, or okay, no problem. Uh, okay, give me 2 minutes. I mean, I think I should open this on Excel. That will be better. Uh, I should go to data, and in data I have fan, transaction, fan, user. I hope should be, at least in the screen. Okay, the shared screen with Excel, right? Uh, I hope you guys can see the section sheet. So in this sheet, if you see, you have user ID. Of course, this is where you get your primary key. It is unique for every customer. And on this user ID only will merge to those two columns, that the transaction data wallet table and the receipt. Okay, so you have registration date, uh, kind of important and not that much important in this case. We will look at that. You have EH look again important because the company is generally like it is known for people have less than 18 years of old, but so it is very evident that the people who have age greater than 20, maybe 25 or 26, are more probable to churn. That's it. City might be a good factor, I guess. Device side, we will have to look at that. Day since registered. So this is, I mean, I don't know from how they're calculating these days, but this should be like, I mean, this is a static data, I guess. For example, this should be like today minus this date, like registration date. So this should be a very big number, but okay, whatever is given is the data we have. Okay. Okay, app open per, this is, I guess, a good column. App open per week. Maybe. I mean, I'm not getting any spike here, but yeah, can be a good column. Second is average session duration, again, a good column. We have, I will do one thing, which is, yes, it's not working. Hmm. Wait. So we have application duration. I have support tickets. I really don't know what support ticket is. So I have to go to that document and I have to check what support ticket is. But for now, I'm assuming it's not very important. For me, it's not important. I guess has customer as card again. I think not important. Has set an saving goal. Maybe important. The last is I have to check. It's no, not the last. Has used offer. I don't know. So I guess you like for the names all evident like what exactly all these mean, right? Uh, I don't have to explicitly tell like what exactly mean of this column. Is active. So this is very one column. This is what is our target variable. We have to look at discount and if there is any sort of imbalance in data, we have to apply that balancing techniques, plot or something, right? Hmm. So okay, this is uh, this is last transaction. It is very important column, I guess. I guess this is the most important column. If you see, because I have already done it, this is why I'm saying this, but because it is evident even right now, if you see, if you have not done any transaction from last 5, 6 years, let's say, so this is not something which is like a international credit card because, for example, you have to do transaction once in a year. No, this is a card which is for children and I mean, this is something which one should use it, right? So if someone not doing transition for last 30 days, 40 days, it's very evident that that person has a very high probability of being churned. I mean, this is what we will see here. For example, if you see the person who has not done transition for last 30 days is zero. Is churned basically. Zero is one, zero is one, 18 is even zero. Okay. 9 is one, 2 is one, 6 is one, blah blah blah. 30 is zero, 15 is zero. If you say 5, 15 is zero, 19 is zero, 3 is one. Okay. 4 is one. If you see, if there's a specific number after which there's a very large uh, population have been churned because of this, because they have not done transactions from last what number of days. I don't know. Okay. Okay. I guess you got a good idea at least about this table. Let's move to the transaction table. I mean, I just want to see what transaction table contains. Uh, FAM pay transaction sample, FAM transaction. Okay. It's not opening again. Okay. I don't know why it's not opening. Should get open right now. Let me see. Can't minimize Zoom workspace. Okay. That is good. Yeah. Yes. So I have my transaction table. Let me share my screen. Transaction table, transaction. Okay, share. Okay. So in this, mm, mm. So if you see, we have transaction ID, user ID. For example, if you see for user ID one, for, for user ID one, you have these many transactions. You see. So this is for user ID one, there are 10 transactions, user ID, there are 1 transaction, basically. And with the transaction date you have, right? So you have transaction date, and you have amount, you have UPI. So you have like payment method. You have for what you are doing transaction and the merchant. So to what merchant you're doing transaction and the status and field is unfilled, right? Okay. So if you see here, the one thing you could do is to sum all the amount for user one and get the total amount. So I would say, like, I could guess one thing, which is like the person who have done lot of transaction using this app, family or something, is very less probable to share. The one thing I could say uh, without any second thought. The second thing is transaction date. So last transaction date again is something you can find here. And from that they can find the duration. Anyway, you have a column, so you don't have to make another column for the same. But yeah, the amount you have UPI payments. So you have UPI payments too. So payment method. So let's see. Like when I don't know, like is it in important transaction type. So I don't know if it's true for FanPay or something, but if you go for different credit cards, for example, there is a very specific credit card for that fuel for refilling your vehicle fuel, right? So for that specific credit card, if you see the people who own vehicle or whatever are very less probable to churn. Not in this not in this case, but for different specific credit card, because that specific card is giving you the whatever cashback or whatever reduction on fuel. That's why people don't get churn because they have card or they have whatever. I mean, they require fuel, and for fuel they want extra benefits, and that extra benefit we don't. I don't think anyone want to leave. Okay, so in this case, I guess not possible. I mean, it's a very not very specific uh, kind of credit card or debit card, but I'm just telling in general. Okay. About a transaction type, I'm not sure, and what a merchant again, I'm not sure. Okay, super. Let's move to the sheet now, and just quickly finish sheet. We have very less time. Okay. Let me go to stop sharing, and I have to share my test type. So let's go to the email part. Okay, I'll go fast for some of these blocks. So this is what I'm importing. This is nothing. This is again importing whatever I have tables. The table of info, I just have to check like what how many columns I have, what columns I have, what is the data type. Okay, again the same thing we have here. So basic univariate analysis for each feature. It's very important. Do this univariate analysis for these kind of problems. Okay. Age distribution, if you see the maximum age is below 18. No, sorry. Yeah, below 18. Again, this is again below 18. This is 1922 and this is 20. Okay. So it is like 35 plus 25, which is 60% of the population is below 18. Okay. And then again, left 40% is and because it's a fake data, that's why the numbers are so good. But yeah. तो the more teen 80% of okay 80% को मैं teen बोला है which is maybe I'm also considering this 90 22 of age so 80% of team prone to high check. Okay. Uh, okay. I don't know why I wrote this, but I would say the person who is more than 31 is more to churn, I guess. But this is what I am assuming right now. This is not, we'll see in the last part, in the what people shape. There's a when we're doing shape or something. So then we'll see like exactly why we are like what exactly the insight from our analysis. For now, it is okay. Like if you whatever you assume here is not an issue. Device type again, Android is more, which is not a big issue. Uh, Same for Android. Okay. So the reason I'm saying this because there are more person in Android, so they're more prone to churn. Okay. I mean, the same thing is here. 80% of people are in this range, in this bracket, that are more to okay. 10 cities count. Again, this is what the count is. Okay. So I really don't need to explain this code. I mean, this is not very difficult to understand. But in case, I mean, this is what you can easily generate using ChatGPT. But in case if you for every where I button this is very easy. I'm just getting the column and I'm just using a function is called value count and I just normalize it. Okay. Because I want to include 0 to 1 into 1 to 100. So for example, I get this and I just want to I just put it in the bar chart using that dot plot method. Bas. This is what I'm doing for everything. So if you go for this distribution of customized card, I'm doing the same stuff again. Okay, so this is for net saving goals. This is for has offered you or not. I don't think this is much important, but yeah. If you see there is a one specific column which is more. For example, here Android is more, there's one is more, again, zero is more, is I mean there are more customers who are not set any goal. Like this is 50-50. This is okay. Okay. Now we have numerical features. All is a categorical. Now we have numerical features. In numerical features, we have plot this histogram or whatever you say. It been 30 because doesn't matter. So we have plot the histogram. This is basically a very uniform distribution. So since register is a very uniform distribution. If you see, so this is not going to a very good column for analysis because if you go to a some specific semester, everyone is almost same old. I mean, it's almost seen as registration days is considered, right? Okay. So second is app opening per week. This is kind of making a bell curve, which is slightly left tilted. But again, this is again not a very good bell curve or something. I don't think again it's going to be a good feature to analyze. Again, so we don't have any good feature in numerical at least. In categorical, how I'll decide, I'll show you later. You have need to use PLDs or something, but right now it is okay. In average session duration, again, it could be a good feature, but again, it's not a very sharp algorithm. Support ticket, again, it's a very uniform distribution. No, referral again, very uniform distribution. This is very important. I mean, if you see last transition data, this is something which have more variation. If you compare the variation apps, if you compare all this six plots, this is more variant. The variation is very high in this plot. So there are very high number of people who have done the last session with 0 to 5 days. Then very less number of people is using this 5 to 30 days. Right. This is very good feature we could use. Again, this is again a very good feature we could use. I'll start okay. So I have written also here. So the last transaction and average screen duration. Yeah. And app opening per week. App opening per week. Okay. Even this could be a possible good feature for us. This is what you have to ensure. Very simple. Target variable. So if you see target variable, so this is the imbalance data set. I have written here. It's an imbalance data will take care of the next notebook, in which when we are going to train a model, we have to oversampling or maybe undersampling also good option, but I have done oversampling for this zero column, right? I have used smart. Okay. The second thing is categorical versus churn. Okay. So now I'm doing bivariant analysis. The second variable is churn. It's very simple because I'm not here for, so I'm not doing very, very deep analytical research on different columns. Okay. So I'm not plotting here any pair plot or something. Okay. I'm plotting columns versus the churn, right? That is active or column, right? So if you see here, for every categorical column, I have stored this in this list, and for every list, I'm calling and sorting the what they complot, right? Complot, yes. Versus is active. Right? This active has to be there. Based on that, we have plotting curve, right? So if you see the age group, I mean, there's nothing much you would see. I mean, so age group one, so that's what I'm saying. For if you see 16 to 18 age is active is one. I mean, they're really active uh, as compared to the count. So, sorry. Between 60 to 80, there are more people who are active. Again, for 1920, more people are active. If you go in 31, so basically, I have to find this percentage. For example, uh, how much this orange block is, how much percent of the total. I mean, I should have done this also. Let me see. This is what I have done for every column. I mean, nothing much. So I have also already percentage. So for I really don't know. So I have written as a lambda function, and I have written it in some chat GPT code, but it is not very difficult to understand. I'm calculating me into 100, and the percentage is 61 percentage. Okay, so this is what I've written a percentage. Right? Group by the column. I should divide by total length. Okay, and sometimes calculate percentage. I hope this is right. This is what you have here. Okay. So if you see, I have written also almost equal percentage 70 to 23. There is a variation with less churn prediction across all degree. Okay. So if you see, I mean, everything is between 17 to 23, right? Yeah. So there is nothing, something, there's nothing, someone which is, there's nothing, some field which is say, oh, for this age group or this specific feature, you have 50% churn or more than 70% churn. There's nothing like that here. Okay. So because the data is not real, that's why it's like that. Okay. Numerical version, the best graph we could plot uh, is count plot, or I would say the box plot. Sorry, the box plot, not count. Okay, so the box plot is here. So box plot, if you see again, similar. I mean, so because so the days since register is uniform everywhere, that's why for 0 and 1, for the churn, for the people who have active and the people who have not active. It is similar if you see. I mean, there's nothing much different there. So, in both cases, they have maximum value of 350 and they have minimum value 0. The mean is around 200, right? For every column, I guess, for every field, you have similar results. So, I mean, these are not good columns to add in your analysis. This could be a good column. Support ticket by churn status. I really don't know what this means, but this could be a good column because there's some variation in this too. This is exactly same. I mean, this is the worst column. It's okay. This is very good column. This is last state transaction, as I said. So because last state transaction has a very much variation in that because there's a specific number of people uh, who have done transaction uh, in last, I would say 1 day or 2 day, and there are very much there are again a very chunk of people who have not done interaction in last 10 days or something. So that is somewhere we have this uh, a separation we could see. So this is a very good column for analysis. So I have written there also like the day since last day transaction is definitely a good column feature. As we can see, the very clear separation between the base on the churn to blah blah blah. Okay. Okay, this is the correlation matrix. If you see, there is not much correlation except with it is a correlation matrix with exactly. Okay. Our target column. So if you see there's not nothing much correlation between this sense transaction and sorry, so there's a very good correlation between this larger transaction and the is active. This is what we are uh, hoping to because of this or uh, the the histogram we have plotted earlier, right? So not much correlation between the column except for the last column, this column, right? So this is for the first table, what we have done today. Now let's focus on the second table. So second table, the transaction table, anyway they don't have much data. So I have done this in a single manner, so in a single block only. So if you see the most of tremendous success, okay, transaction distribution, which is again good. So this is a it's a actually categorical column. So I have to look at using p value or something, but yeah, this is what we have. Transaction.info became background, but okay, it's okay. Uh, now the feature engineering part. So what feature you would make, you would make here? It's very simple. I mean, I don't have to tell much. Uh, so this is where exactly data science person has to think. So I would say there are so many things in feature engineering. So I would say, so first of all, feature engineering is again a very big task. So one thing is data. One thing is you have to transform your data. The data transformation is there, which has been at the last stage. For example, min-max scalar or something in which you, for example, you are using some uh, distance uh, distance centric algorithm like K or something, right? So for that you have to do data transformation, which you have to do if you are in a numerical column. Mm, okay. There is data transformation. There is you have to make new features also. So there is something called you have to make new features. There's something called feature extraction also. There's one thing more I would say I'm not able to recall. Uh, Let me see. Feature engineering, right? I should have written somewhere, but I'm not able to find out now. Okay, no issue. No issue. Um, oh no, it's not, yeah. So this transformation, as I said, there's feature uh, feature mapping or feature construction. One is called feature selection, which is not very different, where you have to like, which we are also going to do, and you have to select features out of so many features we have, which is very important. Again, there's something called feature extraction. That's where we don't have to look much because that is something which have to make completely new features out of the feature you have. So this is not we're going to do right now, not feature extraction. At least going to do feature construction and transformation and selection. Okay. So let's do first is feature construction. This is feature construction which I'm going to tell you right now. So these are the list of features we're going to make. There's a total transaction, total amount. It's very simple for every user ID. You have to compare. It's for the ending. With the total amount you have. Uh, and for that, you can find the average amount, divide by the number of count you have, divide plus the maximum amount. Again, you have to put the maximum function and minimum amount. Very simple. Active days, again, it's a very simple function. I mean, how many days you're active. It can be easily found using yeah, this is but you have to find uh, the like how many times you have done transaction, I guess, right? So this is what you're doing here. So you have just to find the unique number of transaction date. Uh, Transaction field data. This is very bad feature I guess I have made because every time most of time this is success. So, yeah. Okay. Doesn't matter. This is what I have made here, and you can go through the code. It's not much you have to do. Uh, for each group, I have found these stuff, right? Uh, Again, I have aggregate those things. Okay. This is again, I don't have to do this because I already have a column in my user table, right? For this, for the last transaction. Okay, not for last for survey, but at least for this, uh, days since the last transaction, right? Now so because I thought I should use this at least from today, how many days they have not uh, do the transaction as a fun of that also. But anyway, I mean, there could be, so this is where actually, I mean, even we have a thing like, so for example, there because the difference is same for me because if you say the last transaction date, or maybe if you take here is today or maybe some other day, but the difference will be same between the users, right? Uh, but the numbers will be different. For example, for one, it could be, for example, if it is not because data is for 2021, right? And it's 2025 going on, right? So if the number will come a very big number, I would say, in hundreds will get the number. But the difference between the user will be same. But that number exactly does that number exactly uh, have some uh, does this number, whatever that number you're creating, has some implication on your results? That is what you have to see. I mean, this could be a good exercise you could do. I mean, and again, I mean, I don't think so there would be much because again, we have to do feature transformation, which will scale everything is equal to one. In case of you're using a distance-based model, right? But yeah, this is good. This is a good thought you could have uh, in between, right? Okay, research index, and this is the new column, the new table we have made. If you see for each user, we have the maximum amount, total amount, and whatever you say. There's a very good practice is to verify at least for one user using the Excel. I mean, for example, the total amount is 9,262. I'll go to Excel and at least for first user, I would say I see like what is the sum of the amount. It is 9,262. Correct. So, okay. So at least you should know like you have not written something wrong here because I understand doing calculation in Pandas is very easier than doing calculation in Excel. If it is like if it is data like this uh, this duplicated data like just we have for each transaction, we have in different instances for user, right? So for user one, they have 10 transactions. These calculation can easily be done in Python because you have this group by wala method. But in Excel, you have to do manually like, select stuff and I don't know. They could be better also. Okay. So I have saved this file. I don't know why because it's just to see like how the data looks and I just merge this to table. So this is why this is how I imported this data file and I merged this table on your ID and how left. So while left, I really want my user to be inclusive. Is the right word or not? I am not able to process. So I really want that my user table has to be intact there, and my transaction table will fill a new columns there. Right? Very simple. Is null sum okay? So there are, if you see, there are null values. right? When you have nil values for total transaction average value, blah 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 blah, because there are still some user which are not there in transaction table. That's it, right? So you could drop those because the number is not very much. If you see, I have calculated percentage only about 8% of it. So it's okay to drop 8% of it. I don't think there's much to lose. So I just do drop only and then I will do info, everything is not null. And then I have my last one table, which is the merge table, and I have whole of my what should I say, whole of my data. Now it is the time. So this is what we have done with feature uh, construction or feature engineering. Now we have to make now we do what we have to do feature selection. So this from these out of meaning features, you have to select the important features, which is very which is important for the analysis. Very simple. Okay, no. So what we'll do, just uh, segregate these features into two, the numerical one and the categorical one, right? I plotted for let's do for the numerical first because for numerical it is very easy to do stuff. So I plotted the covariance or correlation matrix uh, for is active as a target or that for that target variable. So what you could see that this is active is so much correlated to this. Okay, so you may wonder why this hashtag why. This is because we while merging we have so this is what you should know. Like while merging, if you have two columns names exactly same, then the Python actually separate those two columns using by adding this underscore x and underscore y. This underscore x is from the left table which we have, and this is for the right table. Let's see the covariance first for these two. It's very good to at least uh, like analyze because this transaction date, whatever since transaction last transaction date, whatever it is for what? Is the data given by the person. So this is not today minus the last transaction date. This is the today minus the last transaction date. So if you see the covariance is exactly same, and it should be because at least for the it is uh, for users between users the difference is same and which is okay. Uh, if you see, this is also a very good column. These are also very good column. I would say this is not a good column. It's a good column. It's a good column. You know, so at least we have a list of columns in numerical. I have also listed it down here. So yeah, top feature is what we have active days and whatever it is written here, right? Very simple. So this is a list of column I have. So I have written a very good code here. This is what I would suggest everyone should do. But it depends. It can change a problem statement to problem statement. But yeah, it's a good practice to do. So what I have decided was I could I would take every column which lies between point minus point 0.5 to point 0.8. Very simple. So if it is one, I will take it. Uh, if it is zero point 0.9, I will take it. If it is minus point 0.9, I will take it. Very simple. Oh, okay. I hope I'm sorry, right? Uh, let me share my screen again. Right. So we are here. So what we are discussing is I've written a code in which I will take uh, every. This is actually a code in which I'm actually uh, putting the weak correlate column, which is to point minus point 0.5, say less, which is no, this is greater than minus point 0.5. definitely, and which is less than zero point 0.5. Right? This is the weak correlated features, and for that correlated features, what I'm doing, I'm dropping those features. Very simple. Good. So these are the weak correlated features, and I've dropped those features. Very good. Uh, so you could see, for example, day since register is not here. It should not be here, I guess. Yeah, it's not here. I have strong features on the column, which is this. And basically, I have plotted this, whatever I would say, with a clear plot. Covariance plot, sorry. This is what we have here, right? This is a very colorful plot, very red. So because both of the columns here are correlated. Now we have transaction failure rate. This is very important. Let me see. Okay, wait. So because we have called calculated rate and the transaction failure rate is very less across the field. So it was zero for all. I don't know how, but it was zero for all. So it said me NP dot true. I mean, it's true. So I checked that all the transaction failure are already at zero. So better to drop this is because if you see for transaction failure, you don't get anything. So because everything is zero. Okay, I have dropped this column also. Now it's come for the numerical uh, column analysis. So whatever column we have selected, I have to do analysis on that also. I have to see like how plots are there for this column too, right? So this is what if you see, this is what we have. Everything is if you see clearly separable. If you see, I mean, this is not that much separable, but yeah, right? Next categorical column. So in categorical column, we have to do p-value analysis basically, and you have to check is that this column is significant for the result. Is it or not? Very simple. So this is what we have. This is what categorical column and why blah blah blah. This is this correct. Okay. This is what okay. So for categorical column, you have to do encodings. Of course, this is what you have to apply encoding. So this is so the count is here is very important. You see, and this is called mutual information. There's something called mutual information. I really don't know what does it exactly does it mean, but the higher the value, it is more relevant to your what should I say feature or the target variable. Hmm. This is what if you see, I have dropped the all low mutual information column for the field. And then I have somewhere calculated p-value. Yes, this is where I calculated p-value. P-value is, I guess, enough to sell features, I guess. So those have p-value less than 5%. I would select 10 for the analysis. This is what I have done. Okay, this is what I have done. And I have dropped cities and device type because their p-value is way too high. So device type is 0.2, right? So I've dropped these two columns and then I have again DA column. So then I've done one hot coding because I have to so this is where the construction sorry the selection part is over. Okay. Now we are entering in the what was that called? Uh, we're entering in data transformation part. The data transformation part for categorical column we have to do encodings because our model train on the numbers, not on the alphabets. Right? So we are doing encoding. It's very simple. I have used one hot encoder. This is pretty simple. This is what I have done in coding. Then you have again the final data frame which you have here is this. So I have done encoding here. Then one thing you have to do is called scaling. This is very important again, which I should have done it also. Yeah. So let's finally scale it. Because, for example, if you're not using a distance-based model, what is a distance-based model? For example, in which you, oh, sorry. If you use a distance-based model, you have to do this scaling. Because in distance-based model, the model calculates the distance in any way, in maybe calculating losses or maybe in the model. For example, KNN, they do clustering based on distance only. Okay. So for that, it should be necessary to you understand that distance, it is not, it should not be the case in which their one column is specifically dependent on a single direction or a single uh, column. For example, a column which has very high numerical value will have a greater influence in calculating distance because distance is, uh, and for example, L2 norm is under root x square plus y square. If the values are x in lakhs and in, for example, and the values of y are in number in thousands, so the influence of x is more. Even though there maybe the difference in x is not that much, the influence will be more. So you have to make sure that you have to equalize those differences. Right? This is a one very good question I have asked in an interview, and I actually got stuck there, which was why are you doing min-max scaling? Why are you doing this transformation? You could have trained the model in such a way that the weight should be uh, the weight for that specific column. For example, in this case, x, which have a very big value, should be set in that way so that uh, uh, the answer should be right. I mean, the weight could be trained in that way, right? I mean, the weight could be trained in that. So the weight could be trained in that way that that model should keep in mind that I have x, which has a very specific big value. I have to show. I have to do penalty or for that. I mean, something like that. Okay. But the problem is, I mean, you could find answers. I love to hear from you all guys. Like, if anyone want to uh, say something about this. But the way I think is like because the way what we find is actually the later implication of doing all this stuff. For example, calculating the distance or whatever we do. After that, we find the weight for specific uh, column. For example, we are doing KNN. And KNN first, what we do, so there's no weight there, right? But I would say, for example, let's take a simple example. Let's say in linear regression only, we are doing this stuff. And and I'm doing using L2 norm or something in error calculation. But for that, based on that error calculation only will get the weight, right? So the weight is the later implication, I guess. I mean, this could be a good answer, but maybe it's not correct. I mean, this is what I thought uh, in the interview, but uh, I guess it's not correct because I was not selected for that company. But okay, let's move forward. I mean, this is what I sort of say. Do scaling, do whatever you do. This is very important for model which have distance inherent in that in it. Uh, Okay, so there's other model which doesn't rely on this. For example, decision trees, random forests, XGBoost. So they are actually comparing model. You should compare numbers. So anyway, X is greater than Y. So I really don't care like by how much X is greater than Y, right? So for that model, you would preferably use a non-scaled version of data. So that's how what I'm doing here is I'm scaling and I'm saving one a scaled CSV file and I'm scaling a non-scaled CSV file also. Yes, one. It's a non-scaled CSV file. And this is a scaled CSV file. This could be used for model like logistic regression or KNN. This could be I could use for XGBoost or whatever model you're saying, I mean, which doesn't rely on instances. Okay, this is the end of this notebook. I hope you have understood the notebook completely. I'll share this notebook later in the last video, I guess. But uh, this is what I have to tell you exactly the way one should do EDA. So let's summarize this all at least as soon as possible because I have taken a lot of time for this video, I guess. Uh, so I would say in EDA, for specifically this churn analysis type of problem, you should understand one thing which is very important. You should go in steps. First step is to do a univariate analysis and see what numbers are coming out. At least see for the distribution, at least see for like how the data is distributed. Is there any separation? Is there any segregation you could do? Second is to do the uh, the univariate after univariate you should do bivariate analysis in which you could plot pair plot or uh, the heat maps in which you could get the analytical the actual numbers like how the target variable is comparable or is correlated to the other features and for on that we can do feature selection, right? For categorical column we should do that p value of the task, which is very important. I should have done this after I done that in more detail, but that's okay. But I would suggest you to look at that also and the what is p value and uh, why that p value is significant for those columns and what you mean by significance and whatever it is. Okay, so this is what you have to do. In feature engineering, what exactly you have to do? You have to do feature transformation, which you have to transform one form of data to another form of data. It is in case of numerical, you are doing scaling. In case of category column, you are doing encoding. Right? In the feature, you have transformation, you have construction. So I have constructed many features based on features we have. There's one thing called feature selection, which you have done it right. Uh, there's one thing called feature extraction, which is something which is not here in this file. But feature extraction is something which is to make a completely new feature out of features we have. And that is something which is generally people avoid. I have seen as so far, but maybe like that could be useful in which you have a lot of variation in your data and you have to find uh, a feature. You have to find a feature which have not that much of variance and not that variance. So, like I would discuss this in some later video. I mean, it's very important to understand also the feature engineering. There's some methods called PCA and there's something other called E-sign or something. So, in which you have data and like you get the direction for the most variant direction in which the variation is maximum, and that to take at the feature. This is something which I will discuss later in some day. Uh, okay, let's leave that for some other day. And this is what we have done this notebook. Uh, I'll do this notebook, I guess, tomorrow, which is this. This is for model training. This is a very, very short notebook on model training because I have not properly done hyper parameter training here, but that is a very important task which has to be done, right? So, because I thought that because the results I got here is very good. I mean, that's why I'm not done the hyper parameter training, but you should uh, understand exactly why hyperparameter training is done, and on the best model you have to uh, do evaluation of your model. So like uh, you have to test your model also, right? Okay. This notebook will do in the next video tomorrow. For now, this is enough, I guess. I, would, I just want to thank you all to for listening me. Okay. So I guess I should stop this now. I'll meet you in the next video where we'll discuss about model training and other stuff. Okay, so I have to stop it, right?